there I be, just running through making a video for 6F, for those that were away. Basically, this is looking at the sum of a sequence, of an arithmetic sequence, and that's called a series. So a series is where we're adding up all the terms. A sequence is just the list of terms. So if we have an arithmetic sequence, then we know our terms are U1, U1 plus D, U1 plus 2D, etc. So if we want to add these all up, we can list them out as a sum, like we did with a problem in 6E. So here's Sn, the sum of n terms is the first term plus the second term, this is our U2, plus the third term, right up to the last term, Un. The second last term you could get is by subtracting one D value. So that's our second last term. That's like our Un minus 1, the term before the last. The second term before the last would be where we're subtracting minus 2D. What we do is we write that again, but we reverse the order. So here's our Un term at the beginning instead of the end, and our U1 term is at the end instead of the beginning. Then we can add the two equations together, a bit like simultaneous equations. So we're just going to go Sn plus Sn. We're going to add those. We're now going to add those two together, and we get U1 plus Un. Sn plus Sn makes 2Sn. There's the 2. Now let's add the next terms. U1 plus D, add together Un minus D. The D's cancel, you can see, and we're left with U1 plus Un again. Whoops. Oh, that little red line's sliding around where I don't want it. So, there we go. If we add the next term, two terms, U1 plus 2D plus Un minus 2D, the two D's cancel, and we get the U1 plus Un again. How many of these have we got? N of them, because we go all the way up to the nth term. So in other words, we can say that 2Sn is equal to n times U1 plus Un, or divided by 2, and the sum is equal to n over 2 U1 plus Un, where the nth term, Un, is also equal to U1 plus n minus 1D. So that leads us to two formulae we can use for the sum of a term. If we know the first and the last term, then we can do Sn equals n over 2 U1 plus Un. If we don't know the last term, then we can just simply go n over 2, substitute our expression, this one here, that gets substituted in for Un, and if you then combine like terms, you come up with a second expression or a second equation. So we can calculate the sum by either the first and the last term and knowing how many terms we've got, or using, if we know the first term and we know the difference and the number of terms, we can also get the sum. So let's practice doing that with this example. There's our two formulae. Here's a very simple series. Obviously, you could just add that up in your head, but let's use the formula. So using the first formula here, whoops, that got a bit wacky. So using the first formula, Sn, we're going to pause and I'm going to realign this because it's doing something strange. Back in a moment. All right, let's try again. So Sn is going to be n over 2, or how many terms have we got? 1, 2, 3, 4, 5. Still going strange. N equals 5. So we've got 5 terms. So we can go 5 over 2. That equals. I don't know what's happening. It's the end of the day. Try. All right, we're trying again. So our sum is equal to 5 over 2, brackets, first term is 3, last term is 19. So that makes 5 over 2 times 22. 2's on that go 11. So our sum is 55. Otherwise, we can do it the other method. The second method over here. We know n is 5. What's our d value? We need to know that in this case. We're adding each time 4. So our sum is going to be 5 over 2, brackets. That is the start of the board that's not working. Brackets. Sorry about all the interruptions. All right, so the second one is S of n equals 5 over 2, and we want 2 times the first term, which is 3, and then plus n minus 1, so that's 5 minus 1, times the difference is 4. So we get 5 over 2, 6 plus 5 minus 1 is 4, 4 is a 16, equals 5 over 2 times 22, and we end up with 55 again. So we get the same result, we just have different information to start with. So that's how we use the formula. That was the first method, and then the second method with using our differences. Here we've got it set up as a sigma notation. So when we use the sigma notation, remember that's just saying adding up all the terms. So let's do A. Our sum's going from k equal to 1 to k equals 10. So that means when k equals 1, then our term is, so u1 is going to be 2 times 1 plus 5, which equals 7. Then we've got up to the end where k is equal to 10. How many terms is that? That will be 10 terms. So our 10th term is going to be 2 times 10 plus 5 is 25. All right, so now if we want the sum, S10, adding up the first 10 terms, we're going to go 10 over 2, brackets, 7 plus 25, adding the first and the last term. So we've got 10 over 2 times 32. 2's in the 32 goes 16. So we're getting our S of 10 is 160. Obviously, if you had your calculator, you could just put that in your calculator using the sigma notation. But here we've done using the formula. The last one I just want to look at is this one. If we've got an arithmetic series, it's got 7 terms. The first term is 5, the last term is 53. So if we know there are 7 terms, and these are our terms here, so U1 is equal to 5. U1 is 5. We know that U7 is 53 because we've got 7 terms. So S of 7 is simply going to be 7 over 2. Then add up your first and your last term. Is 7 over 2 times 58. S of 7 is 7 times, what have we got? 29, which is 203. So that one's fairly straightforward as well. So it's just a matter of knowing your rules, and you'll find all the rules are in your formula booklet. Okay, so that goes through the main points that we went through in class. Hope that makes sense to you, and have a good evening. Bye for now. Thanks for listening.